Good afternoon. Welcome to Discover Engineering, a program to help celebrate National Engineering Week. This program is brought to you by National Technological University and the University of Washington. We are broadcasting from the University of Washington campus in Seattle, Washington. My name is Keith Holzapfel, and I'll serve as a moderator for this program. We have assembled an agenda that I hope will be informative and interesting, attempting to show you about the practice of engineering. We will proceed as follows. First, we will show a short videotape produced by the Bechtel group entitled Engineering, Turning Ideas into Reality. We then have asked three persons with quite diverse backgrounds to give short presentations about their lives and professions as engineers. Following that, the Dean of Engineering here at the University of Washington, Dr. J. Ray Bowen, will make a few remarks. Finally, we intend to leave a few minutes at the end of the hour to respond to questions from our audience, either locally or at sites receiving this broadcast. So with that introduction, we will now show the tape, Engineering, Turning Ideas into Reality.
Engineers are the ones who make the world happen, to make every part of the world happen. I want to be a part of turning vision into reality. So I decided to become an engineer.
When I was in junior high school, my parents were willing to gamble by buying a stereo kit for me to assemble, and I was successful in putting that together, and I knew from that point on this was the sort of thing I wanted to do. The product of engineering is all of the things that we all enjoy every day. From the clothes we wear to the vehicles we drive, the TVs we watch.
I thought this would be a job to allow me to use my skills to solve real problems, practical problems, instead of just theory. And I was right. I'm a computer simulation engineer. You can tell from the name, you use computer to help your design. You build your model in the computer system. You can see your ideas in the computer, and that's really exciting.
Minus 1 minute, 20 seconds, and counting.
OTC to flight crew, close and lock your visors and initiate O2 flow, and have a good flight.
Flying in space is an incredible adventure. It was an opportunity that very few people get, and I was fortunate enough to be chosen for it. When you fly in space, there's really two aspects of the mission that are important to people. One is the mission at hand, and in both the flights I went on, I was tasked to do a repair of a satellite, alien satellite in orbit, which was extremely exciting and challenging from both an engineering and I guess a physical side. The other side, which most people allude to but you don't really talk about a lot, is the fact that when you're up there you spend a good deal of your time just looking out the window. And that in my mind, it was probably the most fun, and when you think back on it, that's what makes the biggest impact on you.
Van Opten is now attaching the grappling bar to the side of the satellite at the same location where he had the capture bar originally.
Okay, it's on. Take me down.
engineering is a piece of everything. Every single thing has either some sort of chemical engineering or mechanical engineering or systems engineering, and it doesn't just have to be a piece of machinery that is engineering. Engineering is everywhere.
Something called a magnetic resonance imaging system. It's a device for making pictures of the inside of the body without hurting the body, without cutting the person open. If the engineers had not gotten involved with this, no one would be benefiting. People's lives wouldn't be saved. This has probably saved thousands of lives each year, this technology. They wouldn't have been saved. There have been scientists in lab coats still publishing papers and winning Nobel Prizes, but engineers make it real.
Most of the work in the engineering and construction business is often viewed by the public as involving moving lots of dirt. But there are occasions, and frequently arising actually, where the work entails not only those basic elements, but also an opportunity to provide for the world a monumental result. I had the personal good fortune of working on one such project myself in the Kingdom of Saudi Arabia in Riyadh, where I was project manager for the King Khalid International Airport, which is a very large, brand new airport that serves as the gateway to that very important country. And the product there is more than just a simple transportation hub. It is a place of great architectural impact and beauty, contains very many important artworks collected from around the world. But the important point is the satisfaction I felt in completing that project successfully was not only in meeting my obligations to our very good clients, but to have contributed to the creation of such a monument that will be recognized around the world.
In the United States, we graduate one engineer for every 10 lawyers. And in Japan, for instance, it's just the other way around. It's 10 engineers for every lawyer. I think that we're kind of going at this the wrong way. There's a number of significant issues, be they environmental or whatever, that need solutions. I think we need the good people, and I'd certainly inspire the good people to come in there to help us out with these problems.
We need engineers. I mean, this whole thing runs on people. It's another overused cliche in the Silicon Valley is that the companies are the people. We desperately need more engineers. It's as simple as that.
It's made a lot of people give me respect in a way that I guess I didn't anticipate, in a way I didn't expect.
Engineering provides a way to contribute to the world. Most of the engineering work results in something, and that's extremely satisfying sort of work.
Welcome back to the University of Washington. We will now move on to the remainder of our program. We have as our first speaker Mr. Ron Bucknam. Ron, recently retired as the president of Converse Consultants Northwest, a national civil engineering consulting firm. He was with that firm for over 25 years, serving as a geotechnical engineer. He is currently developing the Professional Engineering Practice Liaison Program at the University of Washington. So Ron, would you tell us a little bit about being an engineer?
Thank you, Keith. I'm pleased to be here today to see all of you fledgling engineers here in this classroom and all of you out there watching NTU. I'm particularly interested in talking about civil engineering for a couple of minutes, since that's what I've spent the bulk of my life doing, and I find it very exciting. The National Science Foundation, for example, has estimated that by the year 1996 there will be approximately 45,000 jobs in the United States going begging in engineering and science, and the number climbs dramatically in the next 10 years beyond that. I think it's an exciting area to be involved in. It's an exciting time to be involved in engineering. In civil engineering, for example, you may know civil engineering is one of the oldest of the engineering professions. It was originated at the time of military engineering. There were two types of engineering a couple of centuries ago. Military engineering took care of military concerns and war machines, and civil engineering, the profession was primarily engaged in designing and building facilities the civilian population needed. Let's take a quick trip with our imagination and a little bit of memory here, and perhaps we can indicate some of the things that civil engineers do. Think with me about this morning, for example. When you got up this morning, you probably turned on the electricity. In many parts of the country, that electricity was generated by a hydroelectric power plant at a hydroelectric dam. The analysis that went into the water supply for the dam and the reservoir were done by civil engineers in an area called water resource engineering. The design of the dam and the construction of the dam itself were done by dam engineers and construction engineers. They also are civil engineers. The design and construction of the penstocks and tunnels which take the water from the reservoir and conducted to the powerhouse were done by other types of civil engineers, tunneling engineers and geological engineers. And even the design of the powerhouse itself was done by structural engineers. Once the electricity was generated, for example, the transmission lines which are supported by high-tension towers were designed also by civil engineers. You probably turned on the water in your house. The water was derived from, in a lot of places, from wells that take groundwater out of the ground. The design of those wells and the pipelines which bring that water to your community and the storage facilities for that water were all designed by civil engineers. On your way to school, you may have ridden in a car or in a bus on a highway or a road. The layout of that transportation system were designed by transportation engineers. The specific road was designed by a highway engineer, another specialty in civil engineering. As you went along, you may very well have gone through areas where the hillsides were cut away. Those hillsides were designed by geotechnical engineers so that they wouldn't fall in on the road. Geotechnical engineers also designed the embankments that went over low spots, and bridge engineers, another specialty in civil engineering, designed the bridges over streams and rivers on your way to school. As a matter of fact, even the pavement that you rode on was designed by civil engineers, a specialty in pavement design. After school, or perhaps on weekends, there are a number of other things that you see and take for granted in your normal life. Office buildings, for example. High-rise office buildings now reach up to 110 stories in height. Those are designed by structural engineers, a highly specialized area in civil engineering. As a matter of fact, the design and support of the foundations which hold up those very tall, very heavy structures are done by another group of civil engineers, geotechnical engineers, who make recommendations so that those buildings, no matter how high or how heavy they are, settle less than 1 inch. In addition to that, as you look around, there are all sorts of transportation facilities. Railroads, designed by civil engineers. You may live in a city, and if you do, you may very well have subways or light rail rapid transit systems. Those are designed by civil engineers. Pavements at airports are designed by civil engineers. In addition to that, if it rains a lot where you live, like it does in the Northwest, or if it tends to flood when it does rain, surface water hydrologists, who are another specialty area in civil engineering, design methods by which the storm water can be collected and detained so that flooding is averted. And finally, civil engineers take care of the design and treatment of human, domestic, and industrial waste that our society generates. Those include sewage treatment plants and sewage treatment lagoons, solid waste landfills, hazardous waste facilities, and civil engineers are even involved now in the detection and cleanup of groundwater contamination from leaking underground storage tanks. So if you're looking for a profession which not only involves math and science, but also involves dealing with a wide variety of projects that are used by all of our society every day, and also in communicating with a wide variety of people, including other engineers and architects and planners and governmental officials, lawyers, bankers, and concerned citizens. Civil engineering, in my opinion, is an exciting profession to be in.
Thank you, Ron. We now move to a person with quite a different background, Ms. Linda DeMarteau. She, after obtaining her bachelor's degree at MIT, she spent some time at NASA, first at Langley and then at the Space Center, and then spent also a period at the Boeing Aerospace Company. More recently, she went on into teaching in a community college and has, in the last year, come to the University of Washington, where she is a part-time instructor, and she is working towards her PhD in the Department of Aeronautics and Astronautics. Linda?
Well, it's always exciting to talk to young students about engineering and the opportunities that are available today in the fields of engineering. Sometimes as a young student we might not think that we really understand what engineering is all about, and I think that in high school very often we see a lot of information about math and science, and that information, if we're good at math and science, then somebody might say, well, why don't you try being an engineer? But sometimes the understanding of what it means to be an engineer is not really there unless we might have a friend or relative who's an engineer. And in many cases, that's still a limited perspective. And that's why these programs are good, and getting to know engineers in all fields is important to understand what engineering is all about. I was always good at math and science in high school, and so I was one of those students that was encouraged to go on to college and to study engineering. Science did not come, my studying did not come that easy to me. In fact, I worked very hard. But one thing I did know was that I was really curious about airplanes and spaceships, and I wanted to follow that challenge and learn what it was required to find out more about airplanes and spaceships, and so I became an aerospace engineer. One thing that's reflected in my career is really diversity. One thing that you can see from my career is a great variety in terms of experiences. I'm currently studying for my PhD in aerospace engineering, as Keith has mentioned. It's been several years since I've been in school, and so the experience is, again, a new one. Almost seems like a brand new one to me. My hope is to become a full-time university professor and to use these skills to inspire young students to become engineers and provide a role model for those experiences. I began to study engineering when it wasn't really popular for a young woman to study engineering. And I went to a college that wasn't really, didn't really have many women that went there, MIT. And the whole field was full of obstacles and challenges. But there are two attitudes that got me through a lot of my difficult studies. The first one was that I felt that I could do anything if I wanted to and if I worked hard enough. And it sounds like the great American way, the great American dream, but it's true. I think that if you have a positive attitude and really feel like you want to pursue something like engineering, become an astronaut, work on the space program, that it's available to all of you if you work hard enough at it. The second one is the value of education. My parents really instilled in me the value of education. Although neither one of them went to college, they knew that it was really important to invest in that education. That's something that no one can take away from you. It will always be valuable. It's important to be financially secure in a time when the world is not financially stable. And studying engineering would always be an investment to you and to your career. So far, I've realized many aspects of my goal. I did get to work at NASA. I worked at 2 NASA facilities. One was at NASA Langley Research Center, where I got my master's degree in Virginia, and I got to work in an area that pursued stability and control of advanced fighter aircraft. And at that time, there were some stability and control problems of aircraft going into fatal flat spins in certain combat situations. And so we studied the effect of using advanced flight control systems to arrest that stability and control problem. Well, I continued with the stability and control analysis and worked on the Space Shuttle at NASA Johnson Space Center. And as you saw on the tape at the beginning of this show, they showed the little room where everyone sits with their headsets on. Well, I was one of those people. I was an aerodynamic flight controller for the Space Shuttle. And I got to work on the stability and control characteristics of the orbiter as an airplane. And this was something new in the space program, because never before did we have a spaceship that would act like an airplane and would land back on Earth. Johnson Space Center is the home of operations for the Space Shuttle program and other space operations now. And many students think that working at NASA or becoming an astronaut is really beyond their reach. And again, it's been my experience that they're not all geniuses, that they're normal people who have had goals and have worked hard to reach those goals. Setting a goal is important in engineering as well as other aspects of your life. If you have a goal, you can make your ideas concrete. And if you make those ideas concrete, then you can progress towards that goal in a methodical manner. And someday you'll reach the goal and have some of the kind of exciting experiences that I've had in my career. Now, in working at NASA, I worked on not only the stability and control of the Space Shuttle, but also tried to work on fuel anomalies, how much fuel the Space Shuttle would use coming in, landing, when it came deorbited from space and landed back on Earth. If something wrong happened to the orbiter, how much fuel would it use, and determining how much that would be. And what that involved was a lot of flight simulator time and working with astronauts and developing those flight rules and flight operations to get to that point. And it was certainly the most exciting part of my whole career. My career extended to working on some of the other things that you're familiar with in space defense. Did some of that work for Boeing, 4 or 5 years, and worked on some of the Space Defense Initiative kind of work, some of the Star Wars work that you've seen probably in documentaries, and a little bit on the tape at the beginning of the show. I also got involved in guidance and navigation of military spacecraft and missiles. And then after a career in industry, decided that I wanted to start teaching. And so I did start teaching on the community college level and here at the university, and here I am today working on my PhD. So as you can see, engineering is all about challenges. And my life has always been a challenge. I don't think there's any obstacle that can't be overcome. And engineering really offers a variety of these kinds of exciting opportunities to solve in today's world. Thank you very much.
Thank you, Linda. Mr. Robert Schneider is our next presenter. Bob is a senior engineer with the firm of CH2M Hill, one of the 10 largest engineering design firms in the United States. They are a leader in the area of environmental and municipal engineering. Mr. Schneider's area of expertise is in consulting for electrical utilities on matters of power plants, power contracts, and planning studies. Mr. Schneider is also president of the Puget Sound Engineering Council, an engineering society umbrella organization serving the state of Washington. Bob?
Thank you. Contrary to what you may believe, engineering is a fun, rewarding, and exciting profession. And today I'd like to speak about some of my experiences and some of my perspectives that I've gained as a mechanical engineer. It really is fun. Some of the fun is being paid to play with some fairly large, fairly expensive equipment. If you ever enjoyed taking apart your bicycle or playing with equipment at home and fixing it, it doesn't compare to the thrill of having somebody take apart, under your supervision, a turbine generator the size of a house, taking a look and seeing what's wrong with it, and then figuring out how to fix it, put it back together, and have it work again. If you enjoy computers, you just can't imagine the kind of computers that you can use at work. You'd never be able to afford them at home. It's also fun to design things, and that's a very important thing for engineers, because what happens is someone will come to you with a problem. You'll get a chance to sit down with them, figure out what that problem is, go away, think about it a little bit more, take a look at some different alternative solutions, and then create on paper a solution to their problem. And once you've created that solution, then you can go out and figure out how to order the equipment, specify it, and figure out how much it will cost, and then work on building that device to solve that problem. And it's a real joy to go out there and visually look at something in steel and concrete and see what you have done, what you have solved, and to watch it operate. Another aspect I find fun and enjoyable in engineering is the fact that you get to make a real contribution to your community. Personally, when I go up to a remote Alaska city and help them figure out how to solve a problem with their electric utility, I know that when I'm done, the people in that community will be able to better afford the electricity that is a necessity to them. It'll be more reliable service, and that generally the standard of living in that community will be better off. There's a lot of other things that engineers do. It's an area where we get to solve some of the tough problems in today's world. At CH2M Hill, we figure out ways to clean up Environmental Protection Agency Superfund hazardous waste sites. We clean up sewage at sewage treatment plants, figure out what to do with your garbage at municipal solid waste facilities, and also improve the quality of drinking water. I mean, those are a lot of things that are really going to make a difference in our environment, that are going to be important to you and your children. Another aspect of engineering is insights. Being an engineer allows you to look at the world on a different plane. It's kind of a fun way to look at the world too. When I look at a large piece of equipment, I get a chance to see the natural forces at play within the equipment, to visualize that. And those are things that you're taught about in your science classes, and to actually see them in action is really fun. If you're trained in thermodynamics and you're sitting in a room reading a book and all of a sudden you feel a draft, you can look around and figure out what is causing it, what's the source of it. If you understand mechanics and aerodynamics and you go to a baseball game, watching the way the pitcher moves his arm, watching the ball in flight, especially if it's a curveball, and even the way the batter takes a swing at it, are things that you'll appreciate on a totally different plane. The closest analogy I know is art. It's like if you're trained in art and you walk into a museum and you look at paintings, you'll look at the brush strokes up close, and then you'll go back and you'll see the way that the artist has sort of taken those brush strokes and created an image. And that's sort of the way it is with engineering. You get to manipulate the way natural forces occur, and you get a chance to do some really interesting things. Engineering also allows you to participate in a modern society. Being an engineer is more than just having fun and being paid well. Being trained in math and science allows you to be a more active participant in our society. Even if you don't choose engineering as a career, you'll be better able to understand the world around you if you continue to take math, science, and computer courses. You'll be better able to understand the technology that impacts you, and you'll be better able to interact with it. As an employee, for example, just about every job out there has been touched by technology. Today we work in a world economy. It's competitive. There's incredible pressure to put out quality products at a low price and keep the environment clean. To do that, we need engineers and especially people who understand technology. Technology has transformed the way just about every job is done in the United States today. There are many jobs that are done totally different than they were 10 years ago. If you want your car tuned up, you go in and it's all computer adjusted. The old days of sitting there and listening to it and playing with the carburetor or playing with the distributor are over. A lot of those things just aren't there anymore. There are other aspects of the workforce which have changed. If you look at a factory, the influence of robotics in most manufacturing jobs or computer-controlled machinery is just incredible. I mean, even on the television, as we've seen over the past few weeks, being a soldier in the Mideast involves night vision goggles, gas turbine-powered tanks, laser guidance systems, and computer-controlled missiles. Another area where you'll be able to better participate in a modern society is as a voter, and this is especially important. If we want electricity, are we afraid of nuclear power? Are we afraid of global warming that could be caused by burning oil, coal, or natural gas? Or are we more afraid of perhaps fish and wildlife damage that could come from a hydroelectric project? These are trade-offs that we're going to have to address. I know we're addressing them in the Northwest because I've helped several utilities with that. I also know that by putting together least cost plans and looking at conservation potential for utilities, that those are things and those are debates that are occurring right now. And for citizens to meaningfully interact, they need to understand what some of those trade-offs involve. And the more understanding you have of math, science, and technology, the better you'll be able to participate in that debate. These debates and being a good voter involves more than just things like that. On the home front, if you're concerned about a large development in your neighborhood, one of the first things that you're going to find is that there's probably been an environmental impact statement written about it. Well, engineers get an opportunity to write a lot of those environmental impact statements. And you can bet that by understanding science, technology, and math, you'll have a much better feeling when you read that environmental impact statement on exactly what the impacts on the physical environment are. And then if you want to either support the project or oppose it, you'll be in a much better position to do that. I guess in conclusion, if you like fun, you appreciate what's going on around you, and you want to have a good future job, engineering is a wonderful profession. One of the things that most of you should consider is keeping your options open. And what that means in high school is to take math, science, and engineering courses, and computer courses. In college, what that means is take some engineering courses, some science courses, and as Linda said a few moments ago, don't focus in too narrowly at first. Enjoy yourself, take a broad spectrum of courses, and then figure out what it is, what aspect of engineering you really like. With that, I thank you.
Thank you, Bob. As our final person to give a formal presentation today, we have Dr. J. Ray Bowen. Ray is the Dean of the College of Engineering here at the University of Washington and a professor of chemical engineering. He came to the university in 1981. As engineering dean at the university, Ray has been instrumental in the development of the Washington Technology Center, a statewide institution formerly established by the state legislature devoted to joint industry-university research. Here at the university, Ray is seen as a leader in developing programs to attract women and minorities into the study of engineering. Ray?
Keith, it's a pleasure to be here today and to participate in the second National Technological University celebration of National Engineers Week. I was particularly struck by the stories or the little monologues by our three speakers, Ron, Linda, and Bob today, for the diversity of views and experience that they have expressed about engineering and the opportunities that it affords youth of the nation. I also thought that Bob made a particularly telling point that it's not only important that you as high school students become technologically literate, even if you're not necessarily interested in an engineering degree as your lifelong goal, because one needs to have a much more technologically literate society to face the complex decisions that we will have to make as a society in the future. It is virtually impossible to make any decision about our existence without having some understanding of science, mathematics in today's society. And one of the problems that our nation confronts is the fact that so few of our students have opportunity to study science and mathematics in the high schools to the depth that they should be taking them. And in those instances where students do have opportunity, so few of the students actually take advantage of the science and mathematics courses. Without these, it will be difficult for many of you to have a wide horizon of opportunities as you approach the next stage of your education or decision point, whether you would like to go to a university or whether you would like to seek some other career path. If you want to go to a university, I urge you to take as much science and mathematics as possible. The videotape that we showed earlier indicated that science actually is concerned with the discovery of knowledge. I'd like to reemphasize that. All too frequently, we have scientific successes and engineering failures. In actual fact, most of those successes are truly engineering successes. They come from the very hard work of engineers who are concerned with the creation and development of techniques for implementation of scientific discovery into practical applications. And if you consider over the past 5 decades, plus decades of my life, one has seen many applications of scientific discoveries which have changed the range and vision of man's existence. Man can now travel further, has greater capacity for communications, has immeasurably increased human comfort and lifespan, and has the capacity even to travel to outer space. All of these accomplishments derive from the work of engineers. There remain many challenges for engineers of the future. There will be even a greater need for engineers in our society because the world will become technologically more complex, and there will be opportunities regardless of gender or ethnicity. As a matter of fact, one of the great challenges that engineering educators will face over the next decade is the question of whether we can create opportunities for women and underrepresented ethnic minorities within our university environment, whether we can create role models, that is, faculty who come from those identified groups that are presently underrepresented, and at the same time whether we can also supply the needs of the engineering profession. Because if one studies the national demography, the white male who now predominates in engineering is an endangered species. That's strange as it may seem if you look at most of the classes in most of the American colleges of engineering, yet it's true. We need to do this not because of economic necessity, but most importantly because of social justice. And I, like many other deans of engineering, have made a very strong commitment to provide opportunities such as the Minority Engineering Program, Women in Engineering, which help provide opportunities for success for women and minorities in the university environment in the study of engineering. But we've also are supportive of programs like MESA, Mathematics, Engineering, Science Achievement, which attempts to take this message to high schools and to encourage more of the underrepresented ethnic minorities to participate in engineering. I hope that our high school viewers will seriously consider university studies and seriously consider studying engineering. And Keith, at this point in time, I would like to turn the microphone back over to you so there will be opportunity for questions from the audience, the viewers at the remote sites.
Thank you, Ray. There is a number on your screen, 206-685-1860. We have left time, so we'd be very happy to have people phone in questions of our speakers. In the interim, I wonder, we have a local audience here which is comprised primarily of students here at the University of Washington. I wonder if anybody here would have a question, or perhaps would anyone be willing to share a little bit about why they decided to go into engineering? I'm sure you had a wide variety of different reasons. Why did you go into engineering? What is your experience of being an engineering student? I think we can pick you up right there if anybody would like to raise their hand and contribute anything. Anybody with enough courage to... Renee? You've been pointed at? Renee, why did you go into engineering? Renee is a student in the aeronautics department. You see her at the far end here.
I find them a lot like Linda. When I was in high school, I had a fascination with airplanes. I really wanted to learn about how they work. So I did an undergraduate degree in aerospace engineering at the University of Southern California. And along my way through my undergraduate career, I found that I was really interested in controls, which is sort of like controlling the what the airplane does. So now here I am. I just finished a master's here at the U, and I'm working towards a PhD in the Aero-Astro department, just like Linda.
Good. Thank you, Renee. Anyone else? I think most of the other people here are not graduate students, but instead are undergraduate students. They're in their third year. I think some of you I recognize in your third year of study. What's it been like being an engineering student? Is it as much work as everyone says? More work, I'm told. I'm told it's a lot of work. Is it worth the work? I guess you don't know that yet. Tell us a little bit.
Yeah, it's a little difficult to evaluate whether it's worth the work or not, because you haven't been out in the job force much. You haven't been in maybe you haven't been in an engineering job at all, really. And so you're hoping that what you're doing is going to get you a degree in something that you can really enjoy doing, as well as being successful at it. You know, some people are successful at their jobs, but they really don't enjoy it, and you want to do something with your life that you'll enjoy, as well as contribute something to society. And so that's why I went into aeronautical engineering, because I liked spacecraft, I liked airplanes, and I liked tinkering with things when I was a little kid, so I went into aeronautical engineering.
Tell me a little bit about being a student. Is it what you expected it to be?
It's rougher than the first 2 years of college, that's for sure. It's more intense. You're expected to know a little bit more of what's going on instead of being led around through all your, like you are in your lower division classes.
Yes, for our viewers, perhaps I should point out that the education process here at the University of Washington, a person that wishes to go into engineering spends the first 2 years doing general requirements, math, science background, and then at the beginning of their junior year, they come into an individual department, one of 8 or 9 different choices here at the University of Washington. So these last 2 years then, they spend learning the area that they've chosen to major in. I'm told we do have a phone call. Can you put that on so we can all hear it?
Keith,
Yeah. Well, we do have a question phone in, so.
Go ahead. Keith?
Yes. Hello, I can't hear them here, unfortunately.
Ask your question, please.
Keith, calling from Jefferson Technical College in Steubenville, Ohio. You have one of the renowned chemical engineers of the world on your panel. Would it be possible for him to spend a minute or two discussing the future and the possibilities for chemical engineering?
Ray, would you like to tell us something about the future of chemical engineering?
First, I'd like to thank you for the compliment about being one of the world-renowned chemical engineers. Most people call me a comical engineer now. I think the future for chemical engineering is very great. There are many challenging problems left in chemical engineering profession. Many of them relate to better, more efficient uses of energy. The questions of how can you also use limited resources to produce better materials is largely within the purview of chemical engineers. In many cases, there are great challenges also associated with the environmental consequences of chemical manufacture. And I believe that most of the chemical process industry has addressed those problems within the constraints of the existing requirements that have been established by the federal government, but one can foresee as we have greater population densities that there will be indeed another level of challenge that chemical engineers will face in trying to minimize the environmental impacts of chemical manufacture. You oftentimes see fluctuations in any given profession that are somehow associated with the cycles of the industry. And I'd like to comment that in almost every engineering profession, you can expect some period of ups and downs in terms of the cycle of that industry. But nevertheless, having observed that, competent, successful engineers are among the last to suffer the consequences of those economic downturns, and engineers oftentimes are the greatest in demand in periods of economic upturn. The chemical industry experienced such a downturn a few years ago once the federal government decided to place different priorities on energy self-sufficiency within the United States. I suspect that, just citing that particular example, that over the next cycle of several years, because of the current crisis we have about oil supply and who controls it, that you'll see that there's a resurgence of interest in alternative fuels within the United States, and therefore increased employment opportunities for chemical engineers.
Thank you, Ray. Does that answer the question, I hope? Do we have any other questions? How about any further questions from our local audience? Anyone else like to tell me a little bit about? Yes.
I have a comment. He was speaking of how intense the program can be and how intense the whole setting can be.
You mean as a student?
As a student,
yes.
Yeah. And it is really intense. And the thing that makes it bearable and even fun is that you do things that you like to do. So in the Northwest, you can go skiing. Seattle is a great place to go out with your friends on the weekend. You kind of do things that make you happy, and then you do your school, and then the whole thing's terrible. So it's not really uncomfortable. It's intense, but it's fun.
I think you also find that you go to meet people with similar interests, and you develop lifelong friendships. I know I did during your school years. Anyone else have any comments, questions? Yes, one in the back.
I also have a comment in regard to being a student in the program. It is intense, and there is a lot of work that you put into the program, but there's also a lot that you do get out. And there's also a lot of opportunities to be involved and participate in such research projects as the University Getaway Special Space Shuttle payload, of which Linda participates in, Clint, and some of these other students here. And you get a lot of opportunities to meet people in the field and learn what engineering is about and what you put into it. So it isn't just all schoolwork and all book work. There is opportunities to learn a lot more.
So you think it is exciting and certainly challenging?
Oh yeah, it definitely is.
I'd like to make a few remarks about that. I know we've gone through a period of engineering schools being generally oversubscribed to. And there's a feeling out there that unless you're a 4-point undergrad student or a high school student, that perhaps engineering is not the area of interest for you. I think we're beginning to recognize that that's not generally the case. There is room for people with imagination and room for people with goals and dedication to come into engineering, and I think they'll find that it's a very successful profession for people with that background. Yeah, Ron.
I think one of the points that we've missed in this discussion here today, and one that's very important, particularly in the realm of practicing engineer, is the importance of humanities and good communication. We've stressed a great deal whether the point of you high school students concentrating on math and sciences, and this is true because engineering is based in the math and sciences. However, because of the complex nature of our interactive society today, it's increasingly necessary for engineers to be able to communicate effectively. A number of years ago, engineers typically were thought of as those who could do a lot with a computer and knew a lot about math, but probably couldn't read and probably couldn't write and probably couldn't speak effectively, if not legibly. And this has all changed. It's changed dramatically in the last 10 years, mostly because engineers now are those who are putting innovative thoughts and solutions to problems together, and they're dealing with people who are non-technical and need to have the opportunity to understand the solutions and understand the financial and societal ramifications to those solutions. So by no means should we discourage pursuit of the humanities and the ability to read and write and to have a larger sense of the humanities, because the number and types of people you're going to be dealing with are a wide variety, a wide spectrum, and good non-technical and technical communications is mandatory.
Thank you, Ron. I agree with you completely. And Ron here at the university is very aware of these issues and is helping us to introduce some of these peripheral things in engineering into our curriculum. He's developing a course in engineering ethics into the University of Washington curriculum. I'm told we do have another caller, so perhaps we could put them on. Do we have a caller, please? Perhaps we had one.
Go ahead, please.
Hello?
Yes, we can hear you.
This is Betty Warner, a mathematics supervisor in Marion County, Florida. Keith, do you hear me?
Yes, I do. Please go ahead. Yes, I can hear you.
Carly?
We're having a little bit of a problem getting her through. I heard who she was.
Okay. I'm
Okay.
a supervisor of mathematics in Florida, and I wanted to comment on our involvement with our local engineering society in Math Counts, which is for middle school students. And I wonder what else there is involved with the national level with middle school students. That seems to be an area where students make the decisions in math and science that allow them to make the right choices at the high school level. Could you comment on that, please?
Yes, would any of our speakers, Ron, would you like to comment on that?
I know that there's a new program called SEE, that the American Consulting Engineers Council is in the process of putting together, which focuses primarily on picking up where Mesa leaves off in the elementary grades, and is directed specifically at middle school students with the anticipation of getting them interested in engineering on a wide basis. That is the American Consulting Engineers Council in Washington, D.C., and they would be very happy to send you some specific information on that program. They have some videotapes, and some speakers, and it is now an ongoing program. It's excellent.
And tell us again, Ron, where they can get that information?
The American Consulting Engineers Council, and they're headquartered in Washington, D.C.
Okay, thank you. Bob?
There's also a program sponsored by the National Society of Professional Engineers called JETS, which is Junior Engineers in Training. And that's a program which provides a little broader background than just the math counts competition. There are a couple of other programs that are in the investigation stage right now, also by a number of engineering societies. What I'd suggest is that if she enjoys math counts and would like to find out more about what some of the different societies have to offer, there are just a wealth of programs out there. I know that in our area, the Puget Sound Engineering Council is trying to bring together a whole host of different programs. Just about every engineering society has a set of programs geared toward the middle schools or grade schools, and there's just a wealth of resources. So I suggest that she talk to her math counts contact and ask them to put her in touch with some of the local engineering societies, and they'll be happy to, I'm sure.
I'm sure, thank you, Bob. I'm sure a number of the students here have had some contacts before they came to the University of Washington, and probably some of you have had working experiences in the summertime. Have any of you worked in an engineering firm in the summertime? It's a great opportunity to experience a little bit what an engineering person does. Anyone like to volunteer any experiences they have had? Well, I see nobody brave enough. Renee again is being pointed at. Renee is very popular. She came in last, so she gets to sit where she can easily be seen. Renee?
I've worked at TRW, which is in mostly in Southern California, but there.
You did that after you were an engineer, a bachelor's degree, or prior?
No, I started as a summer hire the summer of my freshman year, and I was so lucky to get a job after my first year as an engineer, and it was really neat. You're able to see engineers working, and you get to dabble a little bit in engineering, and it's nice because you get to try out stuff, but they don't expect you to know anything, so you can fall all over the place.
You don't have the responsibilities, huh?
And it's really nice. You get paid as an engineer, so that's really encouraging too. And that's how I knew I wanted to stick with it. So I've been with them ever since 1985.
Good, and you continue to do it then? Good.
We got about 1 minute.
Well, okay. Perhaps we should start to wrap it up then. I would like to thank you for joining us today. We hope we've been somewhat helpful at giving you a glimpse into the profession of engineering. If you have any further questions, I suggest that you talk to your high school counselors, contact your local professional engineering societies and groups, and your local university with an engineering curriculum. I would be more than happy to to give answers to any questions if you would like to write to the University of Washington. Thank you very much.